Okay. All right. Okay. All right. Welcome, guys. Good to be here again. Like we said, we're trying to see how we can have this like a series come every Friday as long as we have time and the opportunity to do this. So, like Toby rightly said, we would be looking at how to like get into data, the foundations, and what it entails to get into data. And last week we did establish that um, data has many fields, like subcategories and whatnot. But then we understand that there are some very common fields in data that most people would want to, plunge into and stuff. So I was just be streamlining my thoughts to the three common ones. But again, like I said, there are um, more than 100 fields in data analytics that I'm sorry in data generally that you can actually venture into. So my focus this evening is going to be how do we get into the field of things like data analysis, data science, and data engineering. All right. I'll be talking about things like the foundations, the tools that are expected of us, and then probably some extra soft skills that we would need, to help us plunge out and become better versions and all of that. I like the fact that Timothy is here, and he said aspiring data analyst. Yeah, in fact, no, Timothy, I think you're a data professional. If I'm not, I think you just only need to just brush up your skill and all of that. And Timothy, we've been interfacing for a while, and been going through some trainings and all of that. But I think he's not a newbie as far as I'm concerned. So he wouldn't be in a good position to be using things like aspiring, and all that. Yeah. But anyway, that being said, so I'll just get started to it and we'll see how it goes. Yeah. So I'll start with data analysis, and then I'll go to data science, and then data engineering. So data analysis. I want to believe a lot of us here would have heard one way or the other data analysis, data science, data engineering. It's the buzzword that is out there. It's been in vogue for a while. Some of us are already into it. Some of us are trying to get into it. But regardless, whichever level you are, there are some core things that are foundational that sometimes if you miss. Last week I was talking about my story and I said you can't rule out the place of mentorship, right? Because you need mentors to hold your hand in this journey or in this field. They would be able to guide you, tell you things that would easily, get you on track and things like that. For me, when I started learning data analysis, I think I started with some very core programming languages, and I felt like a little bit discouraged because for me, I've never done anything relating to programming and whatnot. So it was a bit it was confusing. I started with R programming, and learning R on my own was kind of difficult. And then I left R, and the day I finally got in touch with Microsoft Power BI, that was like a turning point for me. But then at the end of the day, I still discovered that there's supposed to be like a sequence of some of the tools you're supposed to learn. All right. When you learn in that sequence, it helps guide you. All right. So sometimes when you go to platforms like Data Camp, they already have like a curated workflow of some of the courses you're supposed to take when you want to you're aspiring to become a data analyst and things like that. So one of the foundational things that you would get yourself started it as a data professional is what they call data literacy. All right, data literacy. It's a foundational course, mostly theoretical, but those things would help you and help guide you in your journey long term. Now, when we talk about data literacy, we're talking about what are those fundamental things that as an analyst you're supposed to know, whether it's ethically, security wise, how to interact with people, how to interact with your audience, and whatnot. So there's a course that is called Foundations for Data Literacy. All right. Some organizations do teach that. All right. But like I said, it's mostly theoretical. So you would take courses like things like data ethics, data, types of data, storage of data, data governance, data security. These things are very, very important because when you get into an organization or you're working as a freelancer, there are certain things you're not supposed to do ethically that a lot of people do not even know or are not even aware of. All right. So in a bid to not just jump and start getting into tools, because one of the things I noticed in my little experience of training and consulting is that a lot of people just want to jump into tools. We're very excited about, learning tools. As good as those things are, we're not downplaying them, but we're simply saying that if you don't get the foundational knowledge, you would run into so many problems long term. All right. So data foundation of data literacy is very, very fundamental as an analyst getting into it. Then another thing I would also say is you can't run away from statistics. All right. As a data analyst or as a data professional, you need the knowledge of statistics. That would help you in how you're going to interpret your data when it comes to things like maybe you're trying to interpret scatter plots, you're trying to interpret visualizations that you have done. A lot of people just love to build visuals, but then I heard somewhere someone said something about that as an analyst, if you build dashboards or reports and you can't bring out any insight from those reports or dashboards, you're not different from a graphic designer. No shade to any graphic design person here. I know Toby does graphics a bit, full time. Yeah. So, but no shade to graphic guys. But we're just simply saying what differentiates you from the other person is your ability to design a report or a dashboard and still bring out meaningful insights from the dashboard or report, as the case may be. So, statistics is a very very fundamental skill. That the knowledge of statistics is a very very fundamental skill that one should have. Now in statistics, we know that statistics is very broad, but then you would there are some what do you call it, platforms that when you're taking courses on, you see statistics for data science, statistics for data analysis, and statistics for data engineering. So because it's very broad, we don't expect you to do everything. All right, so you at least you know a little bit of, okay, what does the mean, mode, median, things like that. You do your central measures of tendencies and things like that, and whatnot. All right, you do your quartile range or interquartile range, fifth percentile, and all of those little things and whatnot. Then a little bit of maybe probability, regression, correlation. You will do some of these things because there are some visualizations that if you want to interpret them, it is your knowledge from statistics that makes or helps you with interpretation. All right. So it's not just enough, like I said, it's not just enough to just build visuals. You need to be able to interpret them and bring out what you call it now, insights from them. Now, moving away from statistics, now we want to get into the tools. All right. We're trying to get into the tools. Now, getting into the tools, a very, very fundamental and very, very core tool for us as analysts, regardless of whatever field of data you're looking at, is at least get a knowledge of Excel. Get a knowledge of Excel. Now, Excel also is very broad. So, as an analyst, we don't expect you to learn every. As a matter of fact, myself as a person, I don't even know everything on Microsoft Excel because Excel has several what do you call it now, usage. All right, there are people that use Excel for engineering, there are people that use Excel for statistics and whatnot and all of that. But for us as data analysts, I think you do things like cleaning data, bringing data into your Excel sheet, um doing things like Excel functions. All right, you should be able to know some Excel functions at best. Things like count, index, match, especially for the lookup functions, H lookup, V lookup, X lookup, and the likes. And things like that. Then a little bit of tables, pivots, know how to introduce pivots and embed them into your Microsoft Excel interface. A little bit of Power Query. You can do Power Query, using Power Query to clean on Microsoft Excel, especially if you're looking at working with very big data, all right, and things like that. Then a little bit of data modeling on Excel. At least if you have a knack of some of these things, you would definitely be very, very comfortable. And like I said, for some organizations, truth is a lot of them may not necessarily be using these very complex tools. I have a friend that works as an M&E officer. What he does basically is just to use Microsoft Excel for most of his data cleaning and transformation and reporting and things like that. So if you have a knack of some of these things, you're good to go. Then after Excel, we'll be looking at a visualization tool. All right. Now, about visualization tools, there are lots and lots of visualization tools that are out there. All right. But again, like I said, based on environment, based on also the organization that you're working on or you're working at, it depends on whatever they are leveraging. So we have things like Microsoft Power BI, which is very, very common in Africa and most organizations in Nigeria. They also have Tableau. All right. Then we have Ultrix, and then we have Nine. All right. We also have a tool called Flourish, but Flourish is a SaaS product. All right. SaaS, that means it's mostly in the cloud. All right. You can't use it offline. You have to use it with the help of help of the internet and be connected to it and have an account. So you have to register, be on it and things. Then we also have Click. All right. So these are just examples of some visualization tools that you can use. You can use them for your data ingestion from a database. You do your data cleaning, you do your data modeling, like trying to connect tables together. Then you would also do things like data aggregation. All right. Like in Power BI, we call them DAX. All right. DAX. That's data analysis expression. That's where you'll be writing some of your calculations and the knowledge of statistics. That's where it comes in. All right. So most of the calculations you'll be doing in data analysis are done using DAX. All right. Then after that, you do things like data visualization, and then you analyze your result and make your presentation and things like that. Then same for Tableau. For Tableau, you have measures, you have columns, tables, rows, and then there's what they call LOD, level of details. Is also used for calculations, especially numeric values. You're trying to count numbers, you're trying to find average, minimum, maximum, and things like, or you're trying to rank information, which is the highest from the lowest and things, whether it's ascending order or descending order, as the case may be. So after your visualization tool, then you can go into a database management tool, which is structured query language, or that's SQL. Some people call it SQL, some people call it SQL. Now for SQL, we have so many IDs, things like Microsoft SQL Server, we have Postgres, we have MySQL, we have SQLite, and the like. So whichever one. The good thing about SQL is once you understand the syntax of SQL, it's the same across board. The only difference in give an example. It's possible that when you write a query in Microsoft SQL Server, you may not need to end it with anything at the end of the query. But say for Postgres, if you write a query, you must put a comma. I'm just giving an example. You must put a comma before that query can run. If you don't put the comma, you might run into errors and things like that. So these are just some of the differences that you would have using SQL. But like I said, once you understand the syntax, you're good to go. And then um, what I would say again is once you've gotten your hands dirty in some of these tools that have been mentioned, and then the foundation that we mentioned earlier, the next thing to do is to start building projects and to build your portfolio. All right. So building projects and building your portfolio, most organizations or most people that I know that are in data use they use, or we use GitHub. Let me put it that way. We use GitHub repository. All right. So you get a GitHub account, register, sign up, and then begin to build your portfolio on your GitHub profile. The reason is because when you're applying for jobs, beyond your CV, which is good, most times, most often than not, what a recruiter would ask you typically is they want to see projects that you've done. They want to see your portfolio. So your portfolio in a way is also like your CV, but it's in a technical way, all right, and stuff like that. So these are fundamentals that if you want to get into data, I promise you, if you follow these things and you're diligent and consistent for a period of time, trust me, the sky is just your starting point. So I think I'll stop here for data analysis. I'll entertain questions before I get into data science, and then we'll continue like that till we get to the end. Toby, I think this is good, right?
Yes, it is indeed. It is a lot shared. I'm glad we have this recorded and we can always post the video up. So far so good. Does anybody have any question? I think we have some bandwidth to take live questions. If you can raise up your hand, I'll just allow you speak if you have questions. Okay, so let's hear from Linus. Linus, please go ahead, unmute yourself and then ask your question.
Okay, good evening, sir.
Hello, good evening. Yeah.
Yeah, my name is Linus Godwin.
Hi, Linus. Good evening.
All right, sir. I want to know for how long does it take somebody who is dedicated to really get successful in data analysis?
All right, good question. I was expecting this question to pop up.
Yeah,
Awesome. Yes. So the truth is, there are no rules to this, and I'll tell you why. There are no rules to this, and I'll tell you why. The reason is because, first things first, we're all different, and everyone has. Let me put it this way. I don't want to use the word luck, but then everyone has a level of grace. Let me put it that way. I think grace is a better term to use, right? So this is it. If I tell you my story personally, you might get discouraged. To be honest, right? Discouraged in the sense that, yeah, discouraged in the sense that not everybody might have my kind of stamina and passion or capacity to hold on. The truth is, a lot of people get into some of these things and they want to see immediate results, right? Which is good. I don't have an issue with instant gratification, but there's also something that comes with delayed gratification. All right.
yeah,
So I'll talk about things like passion. All right. If you're not passionate about what you're getting into, the truth is, if you're going into data analysis or if you're going into tech for money, what then happens when you finish your training and then you're not able to land a job immediately? You get frustrated, right? Sometimes that's the truth. But the truth is,
yeah.
the truth is, if trust me, if you dedicate
O-
6 months to 1 year in learning some of these things that we've outlined here, trust me, there's no way by the end of that duration that you yourself you will not see a difference. So, but this is what I do personally. When I train people or when I'm mentoring people, this is what I do. Even while you're still taking some courses and you're getting into the whole grip and all of that, sometimes what I do is when I see I'm not playing for a job, I just tell myself, there is that you get very comfortable to know that you've learned everything. Just so you know, even myself, I am still learning. The reason is because we also talked about some tools that pops up. So what happens when you finish your training and then you're not able to land a job immediately? You get frustrated, right? Sometimes that's the truth. But the truth is, do you
Yeah,
understand? Yes, when there's a new modification, I would still need to learn them, right?
of
Exactly.
course.
So, yeah, exactly. So the truth is, the learning curve never stops. As long as you're in tech or as long as you're in data analysis or you're data science or you're data engineering, it is always a continuous learning process. That's the honest truth. But the duration for learning, you can give yourself 3 months and say, in 3 months' time, I want to learn these tools. You learn them voraciously, do your practicals, build projects, and you're good to go. I've seen people personally, I won't lie, I've seen people that got jobs 6 months into data analysis. I've seen people that got jobs 1 year. For myself, that's why I said I don't like using my story. To be honest, for myself, it took me 2 years.
Wow, wow,
Yes, exactly. Yes, for myself. To be honest, it took me 2 years before I landed a data analytic job.
wow.
After, yes, after learning. So that's why I don't like using myself because I understand that we're different, right? We're not the
Yeah,
same. So if I
of
tell
course.
you it will take you 2 years, Linus, you'll be discouraged. Is that not so? Let's be honest.
That's
Aha, exactly. But the truth is, you can be better than myself, right?
okay. Good.
Aha. So that's just it. I hope I've answered your question.
Yeah, yeah, excellently.
Oh, okay. All right. Great then.
All right, sir.
Yeah, thank you, Kaselchumfa. So, I like you wanted to talk about another category within data,
Yeah, yeah, yeah,
which was
yeah.
what, data science.
Data science, yeah, yeah. Then data engineering, and then still entertain questions in any of those areas, and see how it goes. I
Okay.
want to just, like I said, just talk about the three common ones that we have out there. But then, for me, my major focus, right, is data analysis, not necessarily data science and engineering and all that. But at least the truth is, I'm like a generalist. I have a little knowledge of here and there, so I can actually just talk about some of these things and just proffer some form of advice and foundational knowledge on it. But my core is data analysis.
Amazing. So let's dig a bit deep into data science and also data
All right.
engineering. Learn
Okay.
about them.
All
Go
right.
ahead.
Okay. All right. That's fine. So um yeah, data science. So the truth is, like I said last week when we started this series of webinars that we're going to be having continuously, the truth is sometimes we don't even know how to differentiate between a data analyst, a data scientist, and a data engineer and things like that. But the truth is they are not the same. And again, I understand how this thing works because sometimes, no offense, but HR, most organizations, HR, they don't really even know the technical side of these things. I belong to a data engineering group on WhatsApp, and I remembered how that 2 weeks ago, a data engineer was being asked in his organization to do some things that a data analyst would typically do, and it was conflicting because the truth is when you work in a very proper organization that everybody understands their role, you notice that they are different, all right? They are never the same. But again, let's dive in. What does a data scientist do? What are the tools? What are the foundational knowledge? You will still need a little bit of data literacy, all right? Data literacy is fundamental across board for everybody. You need to understand why it is important to learn concepts like data literacy, data governance, data ethics, data security. As long as you work in an organization, you're not supposed to publicly share their data. You can even lose your job just by doing that. For some organizations, they sign what they call an NDA, non-disclosure agreement. All right. When you're getting into the organization, sometimes while you're reading your acceptance letter or whatever it is, sometimes they bring what they call an NDA. You sign, they sign. So the truth is, when you go against that, they can take you to court and sue you, all right, just because you disclosed their data to the public, all right. So as an organization, their data is private, is secured. You don't need to publicly share. There are projects I've worked on because it is for an organization. I can never share those projects to the public, whether it's on my social media or on whatever platform I belong to. I will not do that because it is against our ethics as professionals. All right. So we need to understand those things. Then for data security, yeah, we understand things like access. You don't need to um as a professional in an organization, you don't have access to all the data sets that is in that organization. All right, there are levels of access. So you get into an organization and you're at level 7 or something of that sort. Just giving an instance, level 7 has a level of clearance that they give, and they have also their level of access that they also have. All right, so these things are things that you also need to know and understand properly. So data foundation or data literacy is very, very important. Just so we know, the world as it is now has moved from data literacy. We are now in an era of AI literacy. That's the honest truth. I remembered vividly how that there was a time everybody was doing IT compliance and all of those things. The truth is, the world has moved beyond data literacy or IT literacy, as the case may be. Going forward, I have a document. So there's this newsletter I subscribe to, and so what happens is I think quarterly they send out newsletters to their subscribers and all of that. And they sent me a newsletter recently, and I read through it. I think it's 24-page documents. I might share with Toby just so we can also have access to it. So there's a saying that I think in 2025 or 2026, in the next 1 year or 2 years, that if you're not AI literate, you may not be able to land a job. That's where we are gradually getting into. All right. So people are now moving from data literacy, but we understand that the truth is data literacy is still very, very fundamental because you need to understand the foundations. All right. So it's not just to even move with the bandwidth up. Yeah, in this part of the world, it's possible that, yeah, we may not have gotten there yet because of maybe adoption. People are very skeptical to move or transcend to a different technology and things like that. But then it is what it is. The world has moved from data literacy to AI literacy. All right. So I needed to put that out so that we would also know and begin to act towards it. We shouldn't be afraid of AI. AI is not taking over our jobs. AI is helping our jobs become smarter and work seamlessly, as the case may be. So those foundational tools are very, very important. All right. Then getting to the tools, there are tools that um, a data scientist would use. All right, that an engineer may not use or a data analyst may not use. For a data scientist, they are more concerned about using Python. Like a data scientist would use Python to the latter. Like that's their core programming tool. Like very, very important and very core for them. Now, when you learn Python, also we understand that Python is also very, very large. All right. And people use Python for different purposes. So we don't even expect that you should learn the entirety of Python. But then again, you can take courses like Python for data scientists, Python for data analysis, or something of that sort, because we understand that a data scientist would use in Python, there's what they call libraries. All right. So for a data analyst, you might use things like maybe libraries like NumPy, Pandas, Matplotlib, and things like that. But a data scientist would use beyond just NumPy, Pandas, and Matplotlib. They'll be using things like TensorFlow. All right, they'll be using things like scikit-learn because that's what they use for building their machine learning algorithms, whether it's going to be supervised or unsupervised machine learning. And they are more concerned, data scientists are also much, much more concerned about building data algorithms, building pipelines that are tending towards artificial intelligence. All right. So that's what they would use typically. Also, a data scientist would typically use a database management tool. All right. But it depends on whether the data that he or she is working on is a structured data or an unstructured data. Structured data, data that have tabular representation. They have columns and rows. All right, that's what we mean by tabular representation. But unstructured data, data that do not have tabular representation, they are not represented as tables and columns and rows, as the case may be, especially data from social media. So I would always tell people on a daily basis, we generate data consciously or unconsciously. When you go to your socials and you make a post, you like, you share videos and all of that, you are generating data on that platform. All right, but that data is stored somewhere. All right, so a data scientist would use those, data based on their level of storage. All right, what kind of data set they're leveraging, whether it's structured or unstructured. So so when it comes to database management, it's going to be either what we refer to as SQL or no SQL. So no SQL is not only SQL. So no SQL is mostly used for storage of unstructured data. But SQL, most often than not, is used for storage of structured data. All right. Then a data scientist would always embrace every artificial intelligence tool, every AI tool that you have there. So things like UiPath, what do you call it now? Power Automate, that's from Microsoft. Then Google has theirs, just to automate processes and make life very, very easy for them. So very foundational tools, like I said, um, what do you call it now? Data literacy, very, very important for the tools. Python programming, very important, and SQL, very, very important. And then a little bit of cloud computing, especially if you're leveraging artificial intelligence platforms. All right. Sometimes you see data scientists leveraging maybe a little bit of cloud computing, either from Microsoft, that's from Azure, from Google, that's Google Cloud Platform, that's GCP, and then from Amazon Web Service, that's AWS. So either of these three platforms, as long as it does the job. I'm not a pro tool. I'm someone that is geared towards, as long as this tool does the job for me, I'm fine with it. Yeah. So that's about that for data science.
Amazing. Linus, is this a new question or this is your hand raised up again for the previous one?
Sorry, it's previous one. Oh.
Okay. Okay, great.
Okay, okay,
All
okay.
right,
Yeah, it's
Chumfa.
been up for a while.
All right, Chumfa. Okay, so let's learn a bit about data engineering. That's the case with me.
Okay, all right, that's fine. But no questions from anyone for now.
Does anyone have any questions? Okay, Linus' hands is up again.
Line is up again. Okay, all right. Yeah,
Okay,
Niles, please go
since
ahead.
okay, so let's have Linus's question. Just make it
Yeah,
brief and
give it
straight
very
to the
brief,
point,
and
and
then yeah. So
we'll
yeah,
take Timothy as well.
data engineering. Yeah. Okay. Okay. All right. Great.
All right then. Please go ahead, Linus.
Okay, okay. Sorry, my question is coming and coming and coming again.
No, it's
Uh,
fine.
okay, sir. Like we've learned, it's like data science and AI. They have much more relationship than data analytics and AI, right?
I wouldn't say yes, and I wouldn't say no. The reason is because even in data analysis, we are now embracing AI. I'll give you a very typical example.
Okay.
Um, in Excel now, Microsoft rolled out last year what they call Copilot. All right, just the same way you have ChatGPT, you have Bard, you have Gemini and the likes. I think AWS theirs is they call it Whisperers. That's the AI tool. But Microsoft rolled out what they call the Copilot. All right, so Copilot is an AI tool that helps you with a lot of processes, right? Sometimes when I'm writing a query and I don't even want to stress my brain, all I need to do is go to Microsoft Copilot, ask my question in natural language, and it brings out the information for me. I tweak it into my model and I'm good to go. Now, in most Microsoft tools currently, if you have a paid license, all right, so I needed to stress that not free, not crack. All right, if you're using a crack version or if you're using a free version of any of the Microsoft suite, you may not see those things embedded there. All right, because it's not registered on their platform. But the truth is, if you're using a paid Microsoft subscription, whether it's monthly or yearly, there's what they call the Copilot. Copilot has been embedded in all Microsoft tools at the moment, and Copilot is an AI. So I'll give you an example. In Power BI, the tools we use, even on Tableau, all right. In Tableau, they call it Tableau's Einstein. They call it Einstein. All right. So I think they nicknamed it Einstein just because of the whole brain power thing. So this is how it works. When you bring in a data set into your environment, all you need to do is once you have that license and you have the co-pilot, ask in your natural language and tell it what you want to do. Trust me, all it needs to do is it rolls for a while, does the back work and the heavy lifting and all of that, and then it just presents your report in front of you. All you need to do is just try to double check, because the truth is there's also been found out that sometimes AI makes mistakes. All right, so that is artificial intelligence does not mean you just take everything hook, line, and sinker. That's why you also need to know. All right, because sometimes you might refer to something and it might also refer to another thing. Do you understand? So you need to just confirm to find out that what you gave it as the query or as the instruction is what it gave back to you. All right. So
Okay.
yeah. So the truth is, like I said, we are now gradually moving from data literacy to AI literacy. So every data professional, that's the truth, it leverages AI. Apart from even data, other professions are leveraging AI. You're using ChatGPT, you're using Bard, you're using Gemini, you're leveraging AI. You may not even necessarily be in that field at the moment. You're asking questions and all of those things. So we're using AI consciously or unconsciously at the moment. Yeah.
Okay. Okay.
Yeah.
Thank you. Thank
You're
you.
welcome.
Amazing. Thank you, sir. Timothy, over to you.
Okay. My question is a very direct, albeit brief one. So, is it possible for somebody to be a data analyst, a data scientist, and a data engineer all in one?
Okay. Yes. Very good question. Yes, it's possible. It's very possible as long as you have the mental capacity. That's the honest truth. But and again, yes, it's very possible. But again, it just simply means you're dedicating your lifelong vocation to transitioning from one phase to another. All right. So this question you asked, this very question you asked, was something that we had a debate yesterday on my data engineering team. We had a debate yesterday on the WhatsApp group, and somebody was asking a question that is it better to be a generalist or um to be um, one that has specialization in one aspect. And we debated it, and had a lot of talk. And at the end of the day, the conclusion was, as long as you have the mental capacity, don't limit yourself. But this is how it works. When you start from data analysis and you want to transcend, or you want to move, transition into another, it becomes easier. All right. I'm not saying if you want to jump into data science, or if you want to jump into data engineering from scratch, it's difficult. No, it's not difficult. People do it. As a matter of fact, people have been doing it and they don't have two heads. All right. So it depends on your mental capacity. But again, the truth is, when you start somewhere and you want to transition, you know, to another, it becomes easier, because the truth of the matter is, somehow, when you get into it, you notice that all of them are kind of interwoven. They are kind of interwoven. And like I said, the whole goal is to collaborate. People have asked me questions. Amongst all data professional, who is more important? And I tell them everyone is important. It's like in a hospital. The doctor is important, the lab scientist is important, the lab technician, the nurses, the accountant, the admin staff, they're all important. If you take out one department away from that system, the entire system crumbles. All right. It's the same in a typical data environment. Once you take out a data analyst, everybody suffers. If you take out a data engineer, everybody, the other person suffers. If you take out a data scientist, everybody person suffers. If you take out a database administrator, the other person suffers. If you take out a data visualization analyst, who is going to design our report or design our dashboard, and things like that. So everyone is important in the food chain, sort of. But yes, it is really, really very, very possible to transition from one to the other, or to be all of them at the same time, as long as you have the mental capacity.
All right, thank you very much.
All right, you're welcome.
All right, Chumfa, thank you. So let's lastly learn about, I believe, data engineering in another
Yeah,
15,
yeah.
20 minutes. Okay, great.
15 minutes. Okay. All right, great. Yeah. So for data engineering, with all humility, I would say that data engineers are the, how do I put it now? They're like the rock that holds every other what do you call it now? Profession or subcategory in data. They are the ones that does everything that has to do with foundational knowledge in data. All right. I have a book on data engineering foundations and all of that. When I read that book, I understood why it's been said that data engineers are like the core, like they hold the center, all right, in every data profession and things like that. But again, yes, they are not the same with a data scientist or a data analyst or a data business intelligence analyst and things like that. All right. So yeah, you also need foundational knowledge to get into data engineering. You need to know what data engineering is. You need to know things about their ethics. You need to know things about governance. You also need to know things about security. Very, very important. Very, very important. Because most data engineers deploy in the cloud. So you also need to know how to even, you know, understand how the cloud works, what it entails, the security, how to, navigate your way and all of those little, little things. So very, very important. Yeah. So you need knowledge of those foundational tools, all right, or those foundational knowledge to help you, move through that field. Now, beyond that, there's also in data engineering what they call data pipelines, all right, because typically, what is the responsibility of a data engineer? They help us build data pipelines, data structure. They help in giving access to different tools that are either in the cloud or on premise in a server or in an organization, as the case may be. Now, one of the differences between a data engineer and a data analyst, let me just put it this way, is that a data analyst does what they call ETL. ETL means extract, transform, and load. But a data engineer does ELT, extract, load, and transform. They are not the same thing. So this is also how you begin to see that in terms of job description, they are not the same. So, like I said, A data analyst does ETL, a data scientist does ELT. All right. And they all mean extract, transform, load, or extract, load, and transform. All right. A data analyst, I'm sorry, a data engineer has to have knowledge about different operating systems. All right. Most especially Linux. All right. Most data engineers would leverage Linux because of the interface and how flexible it is and things like that. I'm not saying that um the Windows OS is bad. No, that's not what we're saying. Or we're not saying the Mac OS is bad. But typically, most data engineers would leverage the Linux operating system because for them, it has a lot of integration. All right, things like Git, GitHub, and all of those little integrations that you need to get yourself started, and things like those they call orchestrations of pipelines and all of those things. So they have some of those things embedded on the Linux platform, so it's easier for them to just leverage that and then just build on it and stuff. Now, a data engineer also leverages tools like SQL. Very, very important. You need knowledge of SQL and no SQL. All right. So that's to say you're going to be interfacing with both structured data and unstructured data. Like I said, as a matter of fact, they are the ones that helps in storage. All right. Wherever the data is being generated from. All right. It is the data engineers that helps us in storing those data sets somewhere, whether it's in a on-premise server in an organization or in the cloud. All right, where you as an analyst would then go and connect your tool and be able to ingest that data and then clean and then continue from there. So you need knowledge of SQL, very, very important. Then you need the knowledge of Python, very, very important too. As a data engineer, there are some libraries that you also need to know, all right, using Python. All right. And like I said, Python is very, very robust. People use Python for different purposes. People use Python to build games, to build websites, to do, different things. People use it for analysis also. All right. So data engineers also leverage Python programming. Then there's a tool called DBT. All right. It's called Data Build Tool. All right. Data Build Tool, DBT, is a SaaS product. So we'll talk about SaaS. SaaS products? SaaS is software as a service. So whenever you hear the word SaaS, it simply means it's either from a third party that is deployed in the cloud. All right, always in the cloud, not a software that you can install on your local machine or your computer or your desktop, as the case may be. It's always deployed in the cloud. All right, so DBT is a tool also that data engineers leverage. All right, DBT. Then we also have Docker. All right, Docker is also a tool. Docker is mostly used for what they call containerization. All right, they use this as you progress. If you're going to get into data engineering, all right, you would understand that there are times where you need to compartmentalize your data sets, all right, into containers. So Docker is like a container that you install either on your local machine, or you can also, if you have a cloud service, you can also install it in your cloud and then leverage them from there. So they are like containers. They help you compartmentalize your data set and things like that. So you use Docker for that purpose. Then we also have Airbyte. Airbyte is also a tool that can be used. Then there's what they call an Apache Airflow. Airflow is also used by data engineers. We have Terraform, we have Kafka, and then we have Spark. All of these are tools that are also leveraged by the data engineers. Then we also have Airtable. All right, Airtable is like a database management system, just a little bit different, but it's also like a database management system that you can use, to store data, create some form of what you call it now, schedule to send out messages, to send emails, and all of those little things. So all of these tools combined are what you call it now, data engineers use. But again, tools can be overwhelming. To be very honest with us, tools can be overwhelming. I know I've mentioned a lot of tools here that some of us might just be imagining that, okay, yeah, which one will I now learn now, or which one will I? That's, I know questions like that would come up. Tools can be overwhelming. The truth is, when you understand your environment where you are, all right, With time, you then understand that okay, this tool is used mostly in this part of the world. But then the truth is, if you're looking at going global, that's the honest truth. If you're looking at going global, or if you're looking at working remotely, especially as a Nigerian, the truth is you must begin to look beyond the Nigerian ecosystem. You must now begin to look at data from the lens of the world view. All right. So most often than not, I would always tell people, as long as you have the mental capacity, please don't limit yourself. Learn as much as possible. But then your learning should be streamlined. Your learning should be, at least should have a like a guide. Don't just learn because okay you want to learn and then you don't even have like something to help you, gauge your metrics or something of that sort. All right. So the truth is, um there are organizations in Nigeria that if you work as a data engineer that are mostly commonly used. All right. So most times you can, what do you call it now? You can ask questions. You can go online and ask on Google, which tool is this? Based on the percentage, then you begin to have an idea. All right. Like I said, just because of by experience and because of knowledge that is out there, that's why I would say if you're in Nigeria and if you're looking at working in an organization in Nigeria, then you should learn Power BI over Tableau. And why is that? Because most organizations in Nigeria are leveraging Power BI over Tableau. As a matter of fact, Tableau is quite expensive. We're not downplaying them, but Tableau is quite expensive. If you want to get the full package of Tableau, I think it's about a 1,000 US dollars or so. Now imagine you as a beginner that is just getting into data. You've not even made money. You're going to pay $1,000 for just one tool. It's kind of discouraging, right? So most times I don't even advise people to go there. But then there's also what they call Tableau Public. All right. So it's open source. You can download it into your machine. But the only disadvantage is Tableau Public has limitations. So you don't enjoy the full functionality of it. You just enjoy just some sections of it. So there are some kind of analysis that you may not be able to run using Tableau Public. All right. And things like that. So yeah, I think I'll stop here because of time and then entertain a few questions before we wrap up.
Amazing. Wow. Wow. Just a lot to take on. Thank you so much, Chimpa, for those. We have a few
Yeah.
questions here I think we can look at. One is, can you let us know the system specifications that
Okay, that
can
can be
be
best used
best,
for.
yeah,
Okay.
for either of
Okay.
these three
Yeah, of the
skills?
tree. Okay. I want to believe, Linus, when you said system specification, you're talking about your laptop, right? I want to
Yeah,
believe so.
I believe so too. Yeah.
Yeah. Okay. All right. Great. Yeah. So truth is, yes. I was actually looking out for this question. Very very important. Your laptops are very important. Like very very important. You don't, if you buy a laptop that is not, or if you're using a laptop that is not so good, one of the things I can assure you is that you'll be very frustrated. Um, to be honest, first things first, you look out is your RAM. Like if you're getting a laptop for either of any of these tools, like whether it's data analysis, data science, and data engineering, you look at the RAM of that computer. For me now, I would advise you guys if you can get a RAM of 16 gig, any computer that has a RAM of about 16 gig, it's very, very important. Why? Because most times it requires for you to launch two, three tools at the same time, and these tools consumes your RAM. I'll give you just a very typical example. When you launch Power BI on your computer, if you have Power BI installed, what I maybe just trying to learn on your own or in the future, what happens is that Power BI consumes 3.5 gigabyte of your RAM. All right. Now imagine you're using a computer that has a RAM of 4 gig. It simply means you'll be struggling with less than 500 gigabyte for every other application, both the system application and every other application. So your system begins to lag. When you launch Power BI, you notice that the system begins to crawl. Then worse off, if you're now connected to the internet, you'll be very frustrated. In fact, you click on something, it takes over a minute before it responds and all of those things. So very, very important. Please, if you're buying a system, don't buy any system less than 16 at best. All right. You can use 8 gig. It's very compatible. It will work, but then the truth is as you progress, you're doing heavy lifting. I'm talking about something that you can buy once and not even think of buying a system again long term. All right. But then if you're not so maybe financially buoyant and all, you can leverage a system that has about 8 gigabytes, which is good. Then for the RAM, I'm sorry, for the hard drive size, most often than not, I advise you get a hard drive that is SSD, all right, not HDD, all right, because SSD is faster in terms of computational time, all right. So whether it's 256, whether it's 512, and what have you, you can, or a 1 terabyte SSD, it's good to go as long as you might have what do you call it, an external hard drive that you can always connect, store your files and all of those things. But most importantly, SSD over HDD. Then at best, a Core i5, a Core i7, a Core i9, depending on your financial capacity. You're good to go and stuff. So 16 gig RAM, SDD for your hard drive, and then the Intel Core processor should be at least maybe i5, i7, or i9, as the case may be. Any product you can buy, any what do you call it? It can be a Dell, HP, Lenovo, you know, and the likes. But you should be more concerned about the specification of the system. Very, very important because you'll be doing a lot of installation of applications that are very large and would consume space, and at the same time would also require heavy lifting. So we don't want a situation whereby you launch an application and then your system begins to lag and then you're not going to enjoy the experience. It's going to be very, very difficult, trust me.
Awesome. Okay, so we have one here. Where would
Okay.
you advise a beginner to
Right, so
start,
beginner
Excel
to
or
start.
Python?
Okay, no Python. Please start with Excel. Very, very important. Please start with Excel. Excel is not as technical as Python programming. And the good thing about most of these things is just so we know, when you start learning Excel, the knowledge from Excel would also help you when you're learning Power BI, when you're learning Tableau, when you're learning SQL, when you're learning Python and R. All right. So you see things like most of the Excel function you're going to learn. Excel function will help form your brain such that you would understand how programming works. All right, just so we know, Excel is a programming tool. Your Excel function is programming because when you write an Excel function and you miss maybe as little as a comma or you don't put the right syntax, you run into errors. All right, and that's programming. All right, the same way you're going to write those programming languages, but at least you've gotten a hack of how it works in Excel. So when you begin to learn Excel from foundation and you build on it gradually, when you begin to learn other complex tools, it becomes very, very simplified for you. So please start learning your journey from Excel. When you learn Excel, then you can move into a visualization tool and then you build on it and then it continues like that.
Amazing. One last
Yeah.
one, sorry, one last one. How do you manage
All right.
learning tech with a job?
A job. Okay. To be honest, it's not easy. I've been there. To be very honest, it's not easy. But you see, like I would always say, my story is not your story, right? But again, let me make this very, very clear and honest with us. Tech is not a side hustle. I must make this very, very, very clear to everybody. The truth is, tech is a full-time job. That's the honest truth. So if you're looking at doing tech as a side hustle, the truth is you may not go far. The reason is because the same way you're giving attention to your job, that's the same way tech requires for you to give it attention. Let me tell you guys one of my secrets. I study every day, like every blessed day. That's the honest truth. I do jobs. I have a job. I do trainings, but trust me, I study every day, and that's because for me as an individual, it's something I'm used to at this level already. But then I'm not saying everybody must be like Malachi or Kaselchumfa. But I'm just saying that might be what would help you because the truth is consistency is very, very important. Yes, the hustle is real. You need to have a job that pays the bills and all of those things. But the truth is, gradually, if you don't give time and attention to whatever it is you're doing, with time, whatever it is you've also learned will leave you. If you leave Microsoft Excel for 3 months, trust me, when you pick it up again and start using it, it looks very strange in your eyes. All right. That's the same principle with all the tools, and that's the same principle with learning. Whatever you leave over time leaves you. So the truth is, you can start with 30 minutes. You can make up your mind to say, okay, every day, 30 minutes, I want to look at something new. I want to learn something new. new. I want to read about something new. I want to practice something new. Over time, you develop stamina. You move from 30 minutes to 45 minutes. From 45 minutes, you move to 1 hour. For 1 hour, that's how you keep building stamina. And before you know, it becomes a part and parcel of you. And trust me, you get to a level where if you don't study in a day, you feel like you're already missing out something. But that's the way I am at this moment. I try as much as possible to study every day, Saturday and Sunday inclusive. Saturday and Sunday, I don't have a day off. That's the truth. I don't have a day off. I study every blessed day because that's how I stay relevant and consistent. So the truth is, if you want to combine job and tech or job and data, as the case may be, the truth is you must make a lot of sacrifice. There's a lot of sacrifice to be made. And lastly, tech is not a side hustle, it's a full-time job. So the same attention you're giving to your job or whatever it is you have out there is the same attention that requires for you to do it. Let's look at this scenario. Most people go to the university to study BSc in data analysis. Some people go to the university to do masters in data analysis. They spend close to 4 5 years. And the truth is, for some of us, we want to compress all of this knowledge in 3 months, 5 months, and you don't want to show up every day. Come on, guys. It's not possible. All right. So the truth is, you must show up every day. That's the truth. You must show up every day. But then, like I said, give yourself realistic goals. Tell yourself truths. Tell yourself the truth and say, okay, in 1 month or in 2 years, in 1 year, in 6 months, I want to be better than where I am at the moment. I want to have a shift in where I'm going to. And trust me, you will do it. It's very possible. People are doing it, people have done it, and you're not different. Yeah.
All right, thank you so much. Thank you guys. It's been an amazing 1 hour, really. And oh
Hey,
wow.
sorry, I would like to ask a question. I apologize for coming
Oluwaseun.
late. So the
Just because
question,
you are new, go
yeah.
ahead, please.
All right. So the question I
Okay.
want to ask, thank you so much for tonight's webinar. I really learned a lot. So there is the question I want to ask is this education dilemma. Like, are you supposed to get certificate or degree? Now in today's tech, there are some job requirements. You see that
Yeah.
proficiency in so.
Uh-huh.
So should we, if you are navigating the tech space, should you go more for the certification or the degree? I don't know if you understand it, sir.
Yeah. I get your point. Show you went ahead of us. This question you asked is supposed to be something we're going to deal with next week. It's supposed to be the topic for next week, but then I'll just give you like a brief intro. Yeah, you're very, very correct. Yeah, some job description requires for you to have some level of certification, so you need to, and all of those things like that. But again, truth is out there in tech, we're more concerned about the practical knowledge. What can you do? I want to give you a tool. I want you to break this tool for me, bring out results from it. Not necessarily about practical your what do you call it now, your theoretical knowledge. But again, theoretical knowledge helps cement the practical knowledge because the truth is there's no way you would even tell me you know about the practicals if you did not read, right? I don't know if you get you're seeing the what do you call it now, the connection. All right.
Yes,
So
sir.
the truth is all of them are important, but the truth is what makes you different is your ability to have that practical knowledge. All right, that practical knowledge is what stands you out, not necessarily because the truth is you can come with as much certification as you want. We're not downplaying certification. Certification is very important. As a matter of fact, I would even advise that you get certified because it gives you some form of credibility. All right, some recruiters will tell you, oh, when you're certified, you have an added advantage. That's the truth. So you can be certified from Google, you can be certified from Microsoft, and things like that. All right, from Cisco, as the case may be. Beautiful. But then you can be certified and not even know how to navigate a tool because some people are very, very conscious about, oh, I just want to get the certificate. I want to get the certificate. I want to get the certificate. As good as those things are, when you get into an organization, nobody cares about your certificate. They want you to deliver on a project using the tool, and it's more practical out there. So we'll talk about this next week, God's willing. All right, and see how it goes. All right.
Awesome, awesome. All right, guys. Amazing. Thank you so much, Trufa. Thank you, everyone of
Yeah,
spoken
you're
or
welcome.
that was available for tonight's session. It was indeed very, very educative. So look forward to another session next week. And for those of us who are yet to create the account on my sport, please feel free to do so. I dropped a few videos this week on how to create an account, how to set up a profile on my sport. We'll be adding additional how-to videos as well. And yeah, have an excellent weekend and a great week for next week. All right, guys. Thank you so much. Bye.
All right. Thank you, Toby. Thank you so much. Thank you,
Enjoy the
guys.
rest of your day.
All right.